Next, we're going to look at vectors and matrices. So in here you can read about what is vectors and matrices and how important it is in the treatment of geographic or geometric figures. Firstly, vector. So what is a vector? So if we look at this figure, we can see that it's a so if we had a point P, this point have three coordinates values, which is x, y, and z. This also can be represented as a vector P here. So in other words, every single point P in 3D coordinates can be represented as a point vector like that. So if we have two point vector, we can do some calculation. For example, we can add two vectors together like this. So we have vector A is a x, a y, and a z. Vector B is bx, by, and bz. Then we can have vector A plus B is just add the equivalent corresponding elements of these vectors together. So we implement it in Python and see how it works. So in order to deal with a vector, we need to import numpy as np here. Okay. Then we define vector u, for example vector u, or we can say it's a vector A. Is numpy array. So I'm going to type this again here to make it easy to understand. A is going to be numpy dot array, and we put a parenthesis here or round bracket here, and inside here, if we want to make a vector, we need to put it. It depends on if it's a row vector or it is a column vector. So for example, it's a row as a column vector. We can define it by this, that column vector. So we can put the first element in, second element in, and the third element in that way. Similar, we can have second vector, which is b, and we add the value in that way. Okay. Then if we want to plot them together, we just do that, and we get the vector phi with the values in the new vector is 5, 7, and 9, which is exactly as the example in the book here. What if, I didn't try this, but what if we had a vector u is numpy dot array, then we do 1, 2, 3, which is a row vector, like we see that. Then we have v is numpy dot array, and we put in 4, 5, 6. Then we plot them together, and we also have a row vector, and they just add the element in together. So that's it for, or maybe we can do something more. We can do so if we want to multiply a vector with a value, for example this value is 500, and we multiply lambda, multiply u, and plus lambda, multiply v, and we're gonna have this. So if we lambda multiply u, we have this, and then lambda multiply v, we have this, and then if we plus them together, we have this. So that is vector addition, and also multiply a vector with a value or a constant. And if we want to calculate the length of a vector, or it also called a norm to the vector, so length of a vector or norm of a vector, we can, for example, the vector use here. So if we want to calculate the length of it, there are so many ways, but if manually we can calculate it using this way. We can say length of u, and length is going to be numpy.sqrt, which is root square of u first element, and square, then plot second element and square, then plot first element and square, and then we get ulen. Oops, something wrong there. Index 3 doesn't work because this is number 2. Yeah, so we got that is the length of vector u. So that is a normal way that we can calculate the length or the norm of the vector. But actually, we can use a different method to calculate the length or the norm of the vector using Numpy. So in Numpy, we can import from Numpy, import linear algebra, for example as LA. Run that. Okay. Then we can calculate the length of u by call norm function. Then we can have the length of a vector, which is similar to the way that we do manually. So that is different way to calculate the length or the norm of a vector using manual calculation or using linear algebra module from Numpy package.